Okay, so this is our homemade solar panels Prezi. I'm going to go through it with you real quick and let you see how it turned out for us. First off, we really enjoyed having this opportunity to build these circuits and these panels. It was actually learned a lot from it. So to start off, we are Team Pinky and the Brain, and as you can see, pretty clear. So homemade solar panels. Start off. We're going to go to our inventory of supplies. We each one of us ordered our scrap solar cells. I believe we all ordered from the same place. I believe it was Silicon Solar. Um, uh, Mine were pretty busted up when I got mine, so I picked out all the biggest pieces I could get and turned mine into two different series. But we'll talk about that later. Each one of us probably used a small piece of plywood to transport it, as they are very fragile. Solder to do all the soldering iron, wet sponge to clean up the tip of the soldering iron, scissors cuts the tabbing wire and the bus wire and all other things. Two small light bulbs, a flux pen, and some alligator clips. Um, let's see. So there's a picture of some of the stuff. This was Shauna's picture. This is what she used. Each one of us had a little bit different, but anyway, so that's that. Now let's talk about the physics. Here we have a diagram depicting part of Ohm's law, and what Ohm's law basically, states. I guess we can go and zoom in and see. The Ohm law states that the voltage of output on one side of the energy source is decreased, the amount of current flowing through the other side is proportionally decreased as well. This law is valid in electrical conductors under the conditions of low direct currents like solar panel conductors. We see this in effect whenever the solar panels, or with our solar panels, whenever the amount of energy is decreased or the sunlight and heat diminishes the amount of energy or power that is transferred out and allows us to be able to utilize that. The level at which energy can be transferred and used depends upon the concept that's explained through Ohm's law. If we go back and look at this diagram, you can take the volts and the amperage and the resistance. If you have those numbers, you can play with them in the formula and takes it back and forth through. So, also to talk about some of the other things, with the solar panels, they function by absorbing and transferring the sunlight energy into power. This is done through the silicone semiconductor solar cells. So as the heat in the sun transfers their photon rays, well, I'll just say the sun radiates light and heat energy, which is taken up by solar cells, as the waves of energy provided by the sun are called electromagnetic radiation. Within these waves are particles of energy called photons. The photons bounce around and they allow the solar cells allow the photons to transfer their energy. And through those solar cells, they have silicon, which absorbs the photons. It transfers its energy into power, or volts or amps, whichever one you're measuring. The panel is a series of silicon solar cells that are connected by wire so they can conduct current from one cell to another in a single direction. The silicon is a semiconducting material which allows it to be electrically conducive. At the same time it has dual properties. It's a conductor, but yet it still allows for I guess, I just had a brain fart. It's more of not a resistance, but a protector. Like silicone it increases with an increase of temperature. So it increases its productivity as the temperature goes up. Productivity or efficiency goes up. which isn't always the case whenever it comes to energy. A lot of times whenever the heat increases, the productivity goes down. So the level at which energy can be transferred and used depends upon the concept of Ohm's law. Okay. So we covered radiating, we covered energy, we covered power, we covered electromagnetic radiation, and semiconductors. All right, so let's move on a little bit. Zoom to that. Designs. With the designs, we had two different types of designs that we could choose from, that we had to actually produce. In this, we had to produce a series circuit, which in the series circuit, let's pull in here. The series circuit, basically what it is you had a series of panels or cells that were connected from one side, negative side, to the next cell's positive side. And you did that in a series of lines. And if you notice in the diagram here, or on the wires, that it's easier to see in this one. This is the front, that goes to the back. From the front to the back. Actually, I think this one's actually done wrong, so you probably didn't get anything from that one. But if you look over here on this one's done correctly. It goes front, back, all the way around. And it goes from here all the way around, and it's single line all the way there. So you have one end that's a positive and one end that's a negative. That's a series circuit. In a series circuit, what it allows is for higher voltage, but I guess you would say less amps. So depending upon what you're looking for, if you're looking for more volts, you can do it this way. If you're looking for more amps, you may want to do it in another way. So, and we'll go over that again, I guess, in parallel circuits. But so let's go to the next one. So we're going to parallel circuits. In parallel circuits, it's similar, because what you have is you have two series circuits that basically are in line and they're connected together. So you may connect the positives and the negatives both together, and it gives you one series or a parallel circuit, which has, in this case, it has two series circuits in parallel with one another. So what you have is you still have your series circuit where it's front to back, positive, negative, positive, negative, positive, negative. When you get over here, you take this positive and you take the positive from this series and you tie them together, and then you have a lead that comes out here. Over here you take this negative and this negative, tie them together, and it comes out here. So now you have a positive and a negative down here, which then you can tie into your supply, or tie into your battery or your light or whatever it is you're looking for. And what this does is now your voltage will, it's going to be an average, or the lesser of the two cells volts. So in my case, I came up with, basically I ended up with 2 volts from this panel, because each one of my series circuits was 2 volts, roughly 2 volts. And meanwhile, depending upon the time of the day, the amps was about 2.5 amps, or right in that area. Where normally in a series, whenever I tie these together in a series circuit, and I guess I can go back real fast. So on my series circuit, which I don't have, there's not a picture up here of mine, but on my series circuit I ended up getting basically 4.3 volts in series, and at 12 o'clock, at 3 o'clock I got 4.16 volts, and at 6 o'clock I got 3.65 in volts. In amps, I ended up getting, at 12 o'clock I got 2.52 amps. At 3 o'clock I got 2.05 amps, and at 6 o'clock I got 1.65 amps. So significant difference on the time of day as well. I was going to do a chart on that, but I wasn't able to get it to work for some reason. I was having a hard time with my Excel tonight. So anyway, once again, we're Team Pinky in the Brain. Look for us to try and take over the world every time. So I hope you enjoyed the presentation, and that's the end.